Good morning. You had a big one, 24 videos over the last 25 hours, though a handful came in with broken transcripts, so I'll flag those briefly rather than waste your time. You've got everything from OpenAI killing a beloved developer brand, to Xbox's Game Pass catastrophe, to coconuts saving the EV industry. Let's get into it. Let's start with the big developer story of the day, and Theo was not happy about it. OpenAI quietly killed Codex as a standalone product. When you click the Update button on the Codex desktop app, you get the ChatGPT app. The icon might still say Codex if you dig into Appearance settings and find a tiny dock icon selector buried at the bottom, what Theo calls the only proof of Codex's existence remaining, but the product is gone. It's now a mode inside ChatGPT, and the original ChatGPT chat interface has been demoted to a pop-up window inside what is now primarily a coding and work tool. Theo finds this almost cosmically backwards. Regular ChatGPT users open their app to find a code editor, and Codex users open theirs to find ChatGPT. The rebrand is called ChatGPT Work, and to his credit, Theo genuinely tries to cover the good stuff before getting into why he's frustrated. There are real improvements. New plugins for PDFs, spreadsheets, and presentations, integrations with Gmail, Slack, Notion, and Google Drive. A site's beta, he says, is competitive with what Claude and Lakebed are doing. Multi-folder project support, a much-improved in-browser experience with authenticated sites, multiple tabs, and persistent sessions, meaningfully faster computer use, a model picker slider he genuinely likes. And GPT-5.6 being notably better at front-end taste and data visualization. On the Codex side specifically, you can now edit files directly in-app, review PRs without leaving, and hand off from a pro chat to Codex with context preserved, which Theo actually calls useful since he often talks through ideas in chat first. Performance is also better. The old Codex app was overheating his machine. The new one runs cool. His theory is that OpenAI had been running the unified internal app for a while, and the standalone Codex app was quietly on life support. But here's his actual argument, and it's sharp. Codex wasn't just a tool, it was a brand with momentum. People wore Codex merch at events. Grassroots meetups were forming. Jensen Huang emailed Sam Altman personally about how excited he was. OpenAI was reporting 5 times monthly growth. They were buying Super Bowl commercials for it, and now it's a toggle. Theo quotes a community member named Bryce Arrow who nailed it. Instead of, "Hey man, you've got to try Codex," it's now, "Hey man, you've got to try the Codex mode in the new ChatGPT desktop app." That's the whole argument in one sentence. Codex users weren't using it because they needed an AI tool, they used it because it wasn't ChatGPT. That distinction was the product. Theo's other concern is structural. As ChatGPT accumulates more features it wants to surface, sites, chat, the general consumer stuff, developer-specific needs will get progressively deprioritized. The new UI already buries projects and puts sites and chat front and center. He traces the inevitability back to when OpenAI folded Codex model training into the main model line with GPT-5.4. From that moment, the standalone brand had no foundation to stand on. He also brings up Fujisimo, who was the CEO of applications at OpenAI, specifically brought in to run the app side as its own business. She's now moving to an advisory role due to health, and Sam Altman expressed genuine sadness about it. Theo takes that at face value, but notes the person who was steering the application ship is no longer at the wheel, and that matters for continuity. His response to all of this is T3 Code, the open-source Codex clone he built primarily with his collaborator Julius. It was originally built as a hedge against performance regressions or unwanted UI changes, not as a hedge against Codex becoming a toggle, he says, but here we are. As long as OpenAI keeps the app server that the Codex CLI hosts intact, T3 code remains viable. Thousands of users are running forks or patched versions, and Theo actively supports that. The repo even has a Steal Our Code legally button. He closes with something that lands as genuinely sincere, not rage bait. It's a sad way to kill a brand. Codex was too good for Codex. Staying in the AI engineering world, Elizabeth Fuentes from Oz gave a genuinely practical talk on stopping agent hallucinations, and her framing up front sets the whole thing apart from the usual prompt engineering advice. Every LLM call costs tokens in and tokens out, and token waste is a root cause of hallucinations. All 5 of her techniques attack this at the code level, not the prompt level. Her line that captures the whole philosophy: a rule in the prompt, the model reads as a suggestion. A rule in the code, the model cannot skip it. She was demonstrating with a travel agent built on Strands Agents, AWS's open source framework, and running live Jupyter Notebook DMOS throughout, including one where she hit a live error, said, "Oh my God, I have an error, it's real time, sorry," and recovered without breaking stride. Technique 1 is semantic tool selection, and the numbers here are genuinely startling. Her demo agent has 29 tools: flights, hotels, payments, weather, cancellations, all of it. Each tool schema is roughly 70 to 100 tokens. That's up to 3,000 tokens per call just for tool descriptions before the user has said a single word. Her solution: build a local vector database using sentence transformers, which runs free on your machine, and a FAISS vector store, also local and free. Before invoking the agent on any query, you do a semantic search and retrieve only the top 3 most relevant tools. Token usage dropped from roughly 1,000 to 2,000 tokens per call down to under 300. For multi-turn conversations, she also showed a swap tools pattern in Strands that clears the tool registry between turns, so context doesn't bloat across a whole session. Technique 2 is GraphRag. For precise questions involving aggregation, counts, or multi-hop reasoning, replace text retrieval with a structured graph query. The model gets a computed, verifiable answer rather than a probabilistic sample from a document chunk. She mentioned Neo4j OraDB, which has a free tier. Technique 3 is multi-agent validation. A second agent checks every response before it reaches the user. Simple concept, acts as a production quality gate. Technique 4 is what she calls neurosymbolic guardrails, and this is the meatiest part. System prompt rules are probabilistic suggestions. Strands has before tool call hooks that fire automatically before any tool executes. The hook checks parameters. If they fail, the tool call is canceled. She demoed 3 scenarios: confirm without payment, book 15 guests when the maximum is 10, and valid booking with 5 guests. Without hooks, invalid calls go through. With hooks, they're correctly blocked. She also showed an agent control SDK that layers on top of hooks, with 2 rule types: a deny rule for hard blocks and a steer rule that guides the agent to self-correct without stopping entirely. The steer rules live in DynamoDB, so you can update them live without any redeployment. Technique 5 is the distinction between blocking and steering she closed on. Blocking stops the agent and requires user retry. Steering lets the agent adjust and complete the task on its own. That difference, between an impressive demo and an operable system, is where her whole talk lands. For production, she laid out a clean architecture. Strands runs in a container, Lambda functions become tools automatically via gateway, steering rules in DynamoDB, Neo4j for graph queries, and if you want to run everything locally for free, swap in Alama as the model provider. All the code is in the AWS GitHub repo, and she showed a QR code at the start with everything you need to reproduce all the DMOS. On the theme of AI agents in the real world, Rushabh Doshi gave one of the most memorable talks of the batch. He's the founder of Machinecraft, a 100-person thermoforming machine factory in India, 3 generations of family business. And before he touched any technology, he told you why it mattered. The real asset of his company isn't the machines, it's the accumulated knowledge. Customer histories, quotes from 2019, the reason someone got a custom modification. That knowledge lived in his grandfather's brain, then his father's, then his own. High employee turnover meant every person who left took institutional memory with them. The fear wasn't competition, it was forgetting. He built a 36-agent AI system called IRA to solve this. No data science team, no model training. Total build cost, approximately $30,000. An agency quoted him $230,000 for the same thing. It runs on a few $1,000s a month. 0 training bill, 0 GPU costs. The architecture is modeled on biology, which he treats completely seriously. IRA has senses to identify who it's talking to, a gut to digest documents into facts, layered memory, a dream cycle, and an immune system to fight bad information. He stopped thinking of it as software and started thinking of it as something they were raising. Instead of one mega prompt that does everything badly, IRA is a pantheon of specialists. Named agents, Athena runs the room and handles orchestration. Prometheus owns the sale. Plutes handles pricing. Hephaestus owns machine specs. Vera does fact-checking. Memnon guards corrections, ensuring that when a human fixes something, the fix is permanent. Agents hold meetings, argue, and one answer emerges. He called it a boardroom that never sleeps and has no ego. The memory architecture is layered deliberately. Working memory for the last few minutes, pinned facts about specific people, episodic memory of whole conversations stored as stories, relationship warmth that grows from stranger to trusted contact, and a salient gate, essentially a bouncer, that decides what's worth keeping so the brain doesn't fill with junk. When facts conflict, corrections always win. The dream cycle is the part he was most visibly excited about. Every night IRA runs a sleep cycle, replays the day, locks in useful information, hunts for contradictions, gently discards stale data, and converts the day's work into reusable skills. In the morning, there's a dream report waiting: what was consolidated, what was let go, what was figured out overnight. The system literally gets smarter while he sleeps. The soul file is the part he cares about most. Each agent has a conscience derived not from generic safety language, but from the principles of a Jane family business across 3 generations. 5 rules encoded as engineering guardrails. No single source has the whole truth, so cross-check before speaking. Never speak in absolutes, cite, document, and date. Do your own job, not someone else's. Report the truth even when it's ugly. Nobody works alone. Ancient philosophy, running as production guardrails. The product complexity problem he also solved is worth noting. Thermoforming machines serve 7 entirely different markets: hydroponic farm trays, spa bathtubs, EV car panels, medical casings, packaging, and more. Each market has different buyers, different vocabulary, different concerns. IRA understands which world a customer inhabits and adjusts accordingly. It runs 9 go-to-market jobs daily: outbound emails, account briefs before calls, quote generation, a swipe-left, swipe-right qualification mode for outreach, revival of dead leads, inbound reply handling, and pre-call fit assessment. 9 jobs, 1 operator, always on. Golden rule he enforces without compromise: IRA drafts, humans send. He's extracted the whole architecture into a forkable framework called Brain OS, available at forkmabrain.org. It ships as an empty nervous system: agents, memory, dream cycle, soul file all present but blank. You pour your own company's truth into it. His argument: only you can build your company's brain. Nobody can outsource that. Also from the AI Engineer Conference, Sumaiya Shrabony gave a talk that every solo agent builder should probably hear before they build their next agent. Her thesis, delivered with dry, knowing precision: solo agent builders inevitably reconstruct the 5 core pillars of CI/CD, regression testing, monitoring, contract testing, staging, and audit trails, but badly, from scratch, and only after failures. Her own system is a 19-skill cloud-coded agent that runs every other Saturday, reads from a knowledge vault, creates a research brief, builds a content plan, produces 12 content pieces, then runs verifier passes, reviewer gates, deduplication, and saves markdown outputs. It's open source. But the real subject of the talk is the 7 handoffs the system requires. Every arrow between steps is a place where the system can lie to you. When you build alone, nobody catches those lies except you, usually after damage is done. She walks through the 5 reinventions in order. You change a prompt, something breaks downstream, you build a way to test expected output shape. You've reinvented regression testing. Your cron job silently fails for a week, you add alerts. You've reinvented CI monitoring. 1 skill changes its output schema and 3 downstream skills break, you add boundary validation. You've reinvented contract testing. An artifact looks done but shouldn't ship, you add a checkpoint. You've reinvented staging. Something goes wrong and you can't trace which handoff caused it, you start logging everything. You've reinvented audit trails. Each one assembled reactively without recognizing what you're building, worse because it's fragmented. The truly dangerous failure she draws out carefully. Not a bad output you can spot at a glance, but a polished artifact that looks ready but violates your actual quality standards, wrong voice, unverified claim, repeated angle, yet still gets labeled ready to publish. She calls this the agent equivalent of shipping because the code compiled, but the tests never ran. That line is the center of the whole talk. The DMOS make it visceral. She shows naive mode first, happy path, professional-looking markdown output, everything labeled ready. Then she introduces failures. Voice drift. The content reads like generic LinkedIn AI marketing copy. Unlock the power of AI adoption. This game changer will transform how teams operate in today's fast-paced enterprise landscape. Naive mode saves it. Guarded mode blocks it at the voice contract. Missing verification. The artifact cites teams with a clear semantic ownership model reduce AI rollout rework by 37%, specific, confident-sounding number, empty verification log. Naive mode saves it. Guarded mode blocks it. Trust me is not a verifier. Duplicate hook. The content is technically new, but the opening hook nearly matches something already in vault history. Naive mode saves it. Guarded mode blocks it and writes an audit record. She emphasizes the audit record specifically. Boring in normal operation, but when a scheduled run fails silently at 2 am, you need to know which gate failed, which contract was violated, and why. Her prescriptive synthesis is 5 boring gates any agent builder should add deliberately. A pre-save output contract checking required shape, a voice or domain contract, a verification contract for any claims, a dedupt check, and an audit trail. In that order. Her practical instruction, map every handoff. Identify the most expensive one, not the most complex, but the one where bad data causes the most damage. Put your first gate there. Make it block, not just warn. A gate that only logs warnings is not a gate, it is a suggestion. Her final line, before you add another agent, add one boundary. On a related note from the same conference, Jeffrey Lee Chan from Snapchat gave a workshop format talk on his personal AI development workflow built around a tool called OpenClaw. Jeffrey was casual, exploratory, and openly candid about what isn't fully working. At one point, he admitted the experimental content he promised, I haven't even fully gotten working. Which is exactly what makes the talk useful. It's a practitioner sharing in-progress findings, not a polished product demo. His daily workflow at its best, which he estimates is about 70% of the time, looks like this. He describes a task briefly via a short Slack message. OpenClaw maintains context and memory of previous requests so he doesn't re-explain background, and he runs multiple agents with Git work trees, which he emphasizes is very key for parallelization. He showed actual Slack messages he sends to the system. Fix this thing, give it a longer timeout, run the test. They're extremely terse. He observes this with genuine self-awareness. The instructions are so simple that he thinks an agent could eventually replace his role as the human in the loop, and that autonomy is what he's actively working toward. The core reason he uses OpenClaw rather than Claude directly comes down to context specialization. When the orchestrator makes decisions, he wants its context window filled with specs, goals, and task history, not implementation-level boilerplate like Claude. MD files and skills files. He estimates opening Claude directly already burns roughly 25% of the context window with that kind of noise before any real work happens. OpenClaw synthesizes what he wants done, relates it to weeks of prior Slack history, and produces a coherent spec before handing off to workers. Architecturally, OpenClaw uses manager agents that orchestrate worker agents built on a forked open-source agent orchestrator framework. The workers run Claude code, which can itself spawn subagents, creating a multi-level hierarchy. The manager versus worker bias insight is the most practically interesting idea in the talk. When Jeffrey codes directly with an agent, it tends to be optimistic about its own work. It'll say a PR is great and should be merged. The manager agent, operating with different context and no attachment to the work, gave him the opposite verdict on PR 294. It said another PR superseded it, and the first should just be closed. Separating managerial context from worker context gets you more objective code review. For tooling, he showed his terminal setup using CMUX, a multiplexer he clearly loves, particularly for its vertical tab layout and notification system that alerts him when an agent finishes so he can process completions without watching continuously. He introduced Austin, one of CMUX's creators, who was present at the workshop. CMUX has added a Claude Code Teams integration that automatically spawns terminals for subagents, and CMUX SSH for connecting to remote machines. Jeffrey explicitly volunteered he's not paid to endorse it. On models, he primarily uses Codex 03, finds GPT 042 expensive on tokens, and uses MinMax as a budget fallback when his 03 quota runs low. He showed 2 personal side projects built with this workflow. An AI RPG game with a D&D dice roll system, so you can actually fail actions, and a multi-AI synthesis tool that queries multiple models simultaneously and synthesizes their answers. He says he consistently prefers the synthesized result to any single model's output. Shifting to a more philosophical corner of AI tooling, Notice Labs put out a video on building what they call a reasoning expert, essentially a curated knowledge graph you handcraft inside a tool called InfraNotice, and then deploy as a structured reasoning layer inside Claude via an MCP server connection. The idea is to give your AI a visually inspectable brain you can edit and reuse, rather than just uploading documents and hoping the model figures out what to do with them. The presenter is calm and methodical, with a genuinely philosophical streak. They paused mid-demo when the AI generated the phrase, "The mind is one of the world's feedback organs," and said, visibly charmed, "Very interesting and philosophical idea, by the way." That authentic intellectual engagement carries the whole video. The finished product is a visual knowledge graph, nodes sized by centrality, color-coded by cluster, with underrepresented clusters highlighted with a halo effect. The demo topic is ecological thinking. InfraNotice tracks a discourse structure metric. When the graph is too scattered, it flags this and pushes you to add bridging ideas until the structure reaches what it calls diversified or optimal, meaning a healthy balance between coherence and diversity. The modularity percentage metric decreases as bridging statements are added, giving you a concrete signal of progress. Method 1 for building a graph is auto-generation. You type your topic, select AI prompt, then knowledge graph, and InfraNotice sends a broad prompt to Claude asking it to cover the topic as diversely as possible. The result is intentionally wide and dispersed at first. You then use the Gaps tab, which identifies pairs of topics that are distant from each other in the graph, to generate bridging questions. You send those questions to the AI, take the parts you like, add them to the graph, and repeat until the discourse structure reads as optimal. The system auto-tags everything using Wikilink syntax, making it compatible with Obsidian. Method 2 is step-by-step ideation, more conversational and curated. You can toggle Add to Graph, AI messages, on or off to control what gets included automatically versus manually. The presenter demoed granular control. They deleted all but 2 statements from an auto-generated graph, keeping only ideas they personally found compelling. Specifically, to think ecologically is to think in webs, not lines, and rebuilt from there by selecting interesting clusters on the graph, which automatically steers the AI's next response toward those topics. There's a transcend mode for more philosophical or cross-domain connections, which produced the line the presenter added directly to their graph. The mind does not merely notice loops in the world, it is also one of the world's feedback organs. Thought is ecological not when it maps connection, but when it alters its own conditions of perception in response to what returns. They clearly loved it. Once the graph is built, you connect InfraNotice to Claude via the MCP server and reference the graph by name. Claude automatically calls the tool, analyze the content of an existing InfraNotice graph by name, retrieves the structure, and uses it as a reasoning framework for whatever you're working on. You can also make the graph public so others can query it or connect it to their own tools. The closing pitch: instead of uploading documents and having no visibility into how the AI sees that information, InfraNotice gives you a visual, editable representation of the structure. You can see what the AI knows, how the ideas connect, and adjust it precisely. You can edit the brain that your AI is using for thinking. On a very different note, Brian Lunduke announced the first public release of his own Linux distribution, the Lunduke Computer Operating System, or LCOS, and he was clearly personally invested in every sentence. He's been compiling a list of features and ideals he wants in a Linux distro for years, never found an existing one that actually followed the list, so he built it himself. The foundational principles are baked in as hard requirements, not suggestions, and Lunduke was unapologetic about all of them. First, no age or ID verification, ever, not now, not later, not under any circumstances. Second, no online accounts required for any functionality. LCOS must work at 100% capability entirely offline. A text editor that calls home is unacceptable by design. Third, no AI features in the OS itself. His reasoning ties directly to the previous point, since AI features tend to require online services and accounts. Users are free to use AI via browser, but the OS ships with none. Fourth, no weird politics. Political activism has ruined so many projects, and LCOS makes no restrictions on who can use it based on politics. Fifth, no systemed. He gives two reasons: bloat violating Unix philosophy, and that systemed has been moving toward age and ID verification features. Sixth, no forced Rust clones. He's careful to qualify this. He's not demanding elimination of all Rust, but the trend of replacing proven, well-functioning software with untested Rust rewrites is off the table. He cites GNU core utilities as a specific example. The design philosophy is modern capability with a 1990s to early 2000s aesthetic. It's built on Debian without systemed, with his own repository layered on top for insurance, in case Debian ever makes choices he disagrees with. Desktop is XFCE. Display is Xlib, which he calls the future of X Windows on Unix-ish platforms. Browser is Brave Origin, not the full Brave, just the stripped-down, no online services version that's free on Linux and paid on other platforms. Word processor is AbiWord rather than LibreOffice, which he calls very, very large. Media player is VLC. And the terminal is Cool Retro Term with a custom LCOS profile adding subtle CRT curve and scanline flicker for what he describes as warmth, whimsy, and fun. Governance, LCOS is explicitly a monarchy on GitHub. Lunduke is the king with total control, technical and organizational. He's direct about why: to prevent political activists from joining and steering the project, which he says has happened to many open-source projects. He cites personal past experiences. Every small project he puts on GitHub gets flooded with people using profanity, calling people Nazis, defacing wikis. He also mentions the Xlib project, having been defaced by individuals from GNOME and Ubuntu leadership. The Code of Ethics, not Code of Conduct, includes all people welcome regardless of ethnicity, gender, nationality, religion, or politics. Be excellent to each other. PG language only. Meritocracy rules, and Lunduke personally recommends the 10 Commandments, citing Exodus 22-14. He is explicit that this doesn't bar anyone from using the OS. He's also explicit that it stays no matter who complains. Forum access requires a paid subscription to the Lunduke Journal, with lifetime subscriptions massively discounted through July. Version 0.1 is available at Lunduke.com under his projects. He wants broader hardware testing before one, with no fixed release schedule. It ships when it's ready, explicitly contrasted with Ubuntu's 6-month cadence. He's also positioning this as a deliberate pushback against incoming age verification laws in the US, framing more projects taking this stance as providing collective legal protection. Still on the developer tooling front, DIY Smart Code put out a solid walkthrough of Flue, an open-source AI agent framework from the team behind the Astro web framework. It wasn't built as a product. Fred Scott and the Astro team built it to manage their own AI workflows inside Astro's GitHub repo. An engineer from Amplitude encountered it and essentially prompted the public release. The central architectural claim is that Flue runs thousands of AI agents simultaneously without booting a single container. The entire sandbox lives in memory, powered by Vercel's Just Bash, a TypeScript reimplementation of Bash that gives each agent its own sandboxed file system environment without the overhead of spinning up a real Linux machine. Real containers are available as an opt-in for jobs that genuinely need them. The presenter is careful to note no concrete cost figure is attached to the savings, so treat the thousands of agents cheaply, framing as illustrative rather than benchmarked. The video builds around the concept of a harness, the machinery underneath an AI agent that makes it functional, instruction file scanning, MCP server tool integration, sandbox access, and reusable skill loading. The Flue docs are quoted directly. An agent without a harness is not a real agent. Claude code is used throughout as the reference example of a well-harnessed agent. Flue's pitch is that it provides this full harness in a few lines of TypeScript. It's built on Pi, described as a minimal agent core, the same core reportedly underlying OpenClaw. The key distinction from Claude code is autonomy. Claude code requires a human driving it. Flue supports both human-in-the-loop agents and fully autonomous workflows that run start to finish with no human involvement, suited to repetitive, stable processes. The demo walks through building from scratch. Installation is 2 packages, the Flue runtime and the Flue CLI. Running, Flue init lets you choose Node, which produces an HTTP server built on Hone or Cloudflare, which deploys to a worker with a durable object for persistence. Same code, 2 deployment targets. A minimal agent is 5 lines. Running, Flue Connect compiles everything and opens a prompt. Each response includes a receipt, text, input tokens, output tokens, total cost, model used. The most interesting teaching moment in the demo is a deliberate failure. A workflow is given a skill, a Python script that scores YouTube titles, and on first run it fails, saying there are no files on the file system. The presenter explains this is the security model working correctly. The in-memory sandbox registered the skill's description, but not its actual files. Fix 1. Use a local import from the runtime, which runs on the real local machine with full file access. Fix 2. Wrap the Python script in a custom tool. Validate inputs with Valibot. Register the tool on the agent. Same result without granting file system access. Deployment compiles everything into a single server. MJS file, agents and workflows inlined, usable anywhere node runs or on Cloudflare. Workflows trigger via CURL post, return a workflow ID, and a second call retrieves results. Streaming is supported via WebSockets. On Mastra, the presenter notes their prior experience had them wiring sessions, memory, sandbox, and tool loading by hand, one granular step at a time. Flue's philosophy is harness first. All of that comes pre-assembled. They fairly note they're not certain Mastra hasn't simplified since, and they acknowledge Mastra, the Versal AI SDK, and LangChain as real capable tools. The closing provocation. Is Claude code a real agent framework or just a harness you can't program? DIY Smart Code also posted a model review that's really more of a how-to spot AI hype tutorial. QWithOS 9B from a company called Impero AI launched on Hugging Face with viral benchmark claims, racked up 1.25 million downloads in a month, and dominated AI discussion threads for 2 days. The presenter was skeptical and methodical, building a case piece by piece. And what they found is that in every real-world head-to-head test, QWithOS lost to the plain QN base model it was supposedly built on. The pitch on paper is genuinely compelling. Trained on 500 million tokens of Claude-style reasoning traces, native tool calling, 1 million token context window on by default multi-token prediction for fast generation, and it claims to verify its own outputs with tools rather than guessing. The model card shows real benchmark gains, plus 34 on MMLU, plus 30 on strict grade school math, plus 19 on the flexible math variant. The presenter acknowledges these are real jumps, but buried further down the card, not featured in the pitch, GPQA graduate-level reasoning is slightly down, Arc Challenge is essentially flat. Impero's own data selectively leads with the 2 metrics that moved and quietly omits the ones that didn't. The presenter calls this the first crack, and it's in their own data. 3 independent evaluations follow. First, building a full phone interface from scratch, QWithOS versus plain QN, same prompts. Early signs looked good. QWithOS was over 100 tokens per second, and the styling had a genuine Claude-like polish. Then it collapsed. It stopped generating its own files, rescanned its own code 93 times, filled its entire context window, and compacted 3 separate times, burning roughly 500,000 tokens total. The base QN finished the same job in about 90,000 tokens, added working features nobody requested, and ultimately had to come back and fix QWithOS's broken code. Second test, a 3-task coding gauntlet. Task 1, 4 planted bugs including a deliberate trap. Quethos found 3 and correctly ignored the trap. Genuinely sharp for a 9B model. Task 2, generate a working animation from the description, a fire slowly roasting a skewered dish. Colors rendered, labels appeared, nothing moved. Complete failure. Task 3, diagnosing a slow database query. After one nudge, produced exactly the fix a senior engineer would give. Pre-aggregate the subquery instead of scanning per row. Overall verdict, about 70% there. Third test, a day of casual use on a Mac. Built a working clock, to-do list, snake game, and a landing page. Fast, private, fully offline. But the 1 million token context window in practice loaded only a small slice capped by available RAM, and answers kept getting cut off mid-thought. In a direct comparison against a competing 9B model called Ornith running on the same machine, Ornith came out ahead. The technical root cause is the key insight. True knowledge distillation requires seeing the teacher model's full probability distribution. You cannot get that from Claude because you only ever see the single token Claude happen to output. Training on those traces copies the surface style, the confident tone, the shape of the reasoning, not the underlying intelligence. 500 million post-training tokens is trivial compared to a real pre-training run of hundreds of billions. The architecture does the heavy lifting, and Quethos's architecture didn't change from QN. The 3 tells of a hype model card. 1, a download count with no denominator, a million out of how many kept for how long? 2, a benchmark delta with no matched eval receipt. The evaluation setup must accompany the number or the claim is unverifiable. 3, a tag wall when a single small model claims expertise in biomedical, cybersecurity, vision, and agents all at once. That's a marketing surface, not a focus. Any one is a yellow flag. All 3 together tells the whole story. On the interview prep and systems programming front, Coding Jesus walked through a Citadel Securities interview question that sounds simple and is genuinely hard. Write a program that measures the average latency of a cold L1 cache read in nanoseconds. This is not a LeetCode code puzzle, it's a real hardware microbenchmark, and the presenter has clear contempt for the counting Coco's bananas style of interview question by comparison. The concept, a cold L1 cache read, means the data is not in the L1 cache at read time. The first access has to fetch the cache line from a lower cache level or main memory, making it slower than a warm hit. The challenge is forcing that cold state reliably and measuring the latency accurately. The whole thing is implemented in C++. The key insight for forcing a cold read: you can't just read from an address and call it cold. The CPU has probably already cached it. You have to first flood the L1 cache with unrelated data until the target cache line gets evicted, then read it again. That second read is your cold latency measurement. Implementation decisions, and these are the parts that separate strong candidates. Cache line size is obtained using hardware-destructive interference size from C++17 rather than hardcoding 64. This is the compiler's formal answer to what is the minimum stride to guarantee 2 variables don't share a cache line. It could be 64, 128, or something else depending on architecture. The eviction buffer is allocated at cache line size times 2 to the 12th power, roughly 500,000 bytes, comfortably larger than the L1 data cache to guarantee eviction. The trial count is 20,000 for averaging. The eviction sweep iterates through the buffer in steps of cache line size, not byte by byte, because the CPU fetches in cache line chunks and touching 1 byte per line is sufficient. Doing it byte by byte would take 8 times longer for no benefit. A volatile sync variable is declared, and this is critical. Without volatile, the compiler can prove all the reads have no observable side effects and will eliminate them entirely, making the benchmark measure nothing. Volatile forces real load instructions to be omitted. The timing structure. For each trial, record a flood start time, run the eviction sweep, record the flood end time, then do the single cold read of cache line data. Total trial time minus flood time gives the read latency per trial. On the presenter's hardware, the result was 51 nanoseconds average. The part that distinguishes candidates in the room, per the presenter, is proactively flagging the trade-offs. Clock overhead, every call to steady clock. Now, adds its own latency and noise. The hardware prefetcher. The sequential sweep through the eviction buffer is exactly the pattern prefetchers are designed to detect and exploit, potentially prefetching the target cache line back into L1 before the explicit read, making measured latency appear artificially low. Thread migration. If the OS moves the thread mid-benchmark, the cache state on the new core is completely different. Timer granularity. Even with nanosecond duration cast, some system timers are coarser than 1 nanosecond in practice. He also explicitly calls out that knowing why steady clock is preferred over system clock for benchmarking is a follow-up question interviewers will ask. Look that one up. Moving to gaming, Bellular News covered what is shaping up to be one of the biggest implosions in recent gaming industry history. Xbox's Game Pass strategy fell so far short of projections that the company is now in a hard reset, cutting studios, narrowing to franchise-only development, and gambling everything on the upcoming Project Helix console launch. The presenter is analytical and clearly troubled throughout, with a kind of sad but determined to document it accurately energy. The number that anchors the whole story, a Microsoft slide from the 2023 FTC hearings projected 77 million Game Pass subscribers by July 2026. Per Wall Street Journal sources, after a 2025 price increase, they had approximately 30 million. Less than half their target. The entire company was restructured around Game Pass becoming a paradigm-shifting business model, not just a profitable one. It wasn't, so now everything resets. The strategic reset means a smaller portfolio, fewer studios, fewer games, but those games must be bigger, broader, and tied to recognizable brands. The studios cut, Ninja Theory, Arcane, Compulsion, Double Fine, Undead Labs are the wrong type for post-Game Pass Xbox. They make single-player games, new IPs, and cult hits. Without massive commercial power, they can't justify Western developer salaries. ZeniMax took disproportionate damage. Bethesda's focus narrows to Fallout, Elder Scrolls, Doom, Quake, and Wolfenstein. Warren notices in the Maryland region alone show 379 jobs lost out of 1,600 cuts total. id Software in Texas had nearly 200 staff, 136 are gone. Notably, despite Game Pass performance of 3 million players versus an estimated 800,000 copies sold, that success metric now counts against them. The new Xbox needs sales, not streaming plays. The presenter reports that the id Tech Engine team is now functionally gone. Future franchises will likely use Unreal Engine 5, and id had been internally pitching 3 projects. A John Wick-style original called Fury, a new Perfect Dark game, and a co-op multiplayer Doom. All appear dead. Obsidian is a microcosm of the whole situation. 3 well-reviewed games, only 1 met commercial expectations, Grounded 2, mostly outsourced. Obsidian lost a quarter of its headcount. Avowed 2 is paused. A leaked Bloomberg strategy meeting revealed the studio is now focused on a single project, a new Fallout game led by Josh Sawyer of Fallout, New Vegas fame. The twist is that this was originally a new IP, structurally and thematically similar to Fallout. That is being reskinned into the Fallout franchise, so Xbox can have a Fallout title on the market, while Bethesda is occupied with Elder Scrolls 6. That game won't arrive before 2028 at the earliest. Full development only started in 2024 post-Starfield. The contradiction that the presenter finds almost darkly funny. ZeniMax Online was called core to the company just months ago, then got gutted again, 213 more jobs in this round on top of significant cuts the previous year. And the ESO team has to restructure monetization and content schedules yet again. Broader structural picture. 80% of Xbox's revenue still comes from the console, not PC, cloud, or Game Pass, per the Fortune interview. Bloomberg reports exclusives are being discussed again as a console differentiator. Project Helix, expected holiday 2027 to early 2028, is the single remaining bet. The presenter uses Hail Mary explicitly. The institutional losses he's most troubled by. Kevin LaChapelle, VP of Platform who built backward compatibility and the entire cloud product, is gone. The accessibility team is shredded. The creator of Xbox FanFest is gone. Calling that management bloat, he argues, is dangerously misleading. Those people built the actual products. His closing Call of Duty analogy, Black Ops 7 underperformed significantly, likely contributing to many of these cuts. Being existentially important to a company doesn't protect a franchise from being shipped on a business timeline regardless of quality. Every franchise Xbox has now elevated to must ship for Helix status faces the same risk. Shifting over to hardware, Max Tech put out an enthusiastic case for why the upcoming MacBook Neo 2 will be the best-selling laptop in the world. Up front, this is explicitly a hype video for a product that doesn't exist yet, built on leaks, iPhone spec extrapolations, and the presenter's own inferences. He was fired up throughout, particularly on the RAM upgrade, and openly frustrated with Apple's pricing on everything else in the lineup. The foundation. Apple was the only major PC manufacturer with meaningful year-over-year growth in Q2 2026, posting 10.1%, while everyone else was flat or negative. He attributes this entirely to the MacBook Neo launch and uses it as his baseline. 10 reasons he thinks the Neo 2 will be even bigger. The A19 Pro chip brings roughly 10% single-core improvement, 14% multi-core, and 40% GPU performance gain over the A18 Pro. The GPU improvements also benefit crossover gaming and AI workloads specifically, since the A19 Pro has neural accelerators built into each GPU core. The RAM story is where he gets most animated. The A19 Pro brings 12 GB of RAM versus 8 GB in the current Neo. He ran a personal test. After a fresh restart and opening just 3 Safari tabs, the current Neo was already using 6 of its 8 GB, leaving only 2 GB free. With 12 GB under the same conditions, you'd have 6 GB free, 3 times more free available RAM. He frames this as a game changer for multitasking and takes a pointed shot at Windows competitors shipping 8 GB machines at competing price points while giving up Copilot Plus AI feature compatibility in the process. SSD speed is expected to double based on the iPhone 16 Pro to iPhone 17 Pro comparison. And this matters beyond transfer speeds because Apple uses SSD space as overflow RAM. So a faster SSD directly improves how gracefully the system handles memory pressure, which was a documented problem on the original Neo. Charging goes from 20W to 40W fast charging, which he calls a major fix for practical on-the-go use. Wi-Fi 7 via Apple's N1 chip replaces Wi-Fi 6E, with automatic tri-band switching across 2.4, 5, and 6 GHz. He calls it the most reliable Wi-Fi he's ever tested. On chip supply, the story gets interesting. The so-called Tata Electronics dark web leak, described as Apple's biggest leak ever, included an image of the iPad mini 8 logic board confirming it will use the A20 Pro, not the A19 Pro as previously expected. That frees up A19 Pro supply almost entirely for the Neo 2, which he thinks could arrive as early as January, only 10 months after the original Neo. The pricing argument is his closing punch. The MacBook Air M5 just went to $1,300, up $200. The MacBook Pro base model has climbed into territory that used to belong to higher-tier models. A redesigned 14-inch M7 MacBook Pro is rumored for next year at presumably even higher prices. The Neo 2 at $699, or $799 for a potential 512 GB base, becomes the only genuinely accessible Mac in the lineup. His conclusion: with all major Windows competitors still overpriced relative to that $699 figure, and with Apple's other Mac lines becoming increasingly expensive, the Neo 2 will be the best-selling laptop in the world on launch. On the car shopping front, CarEdge put out their July 2026 slowest sellers list, and it is dominated by 2 themes: Stellantis brands and electric vehicles. The hosts, a son who's energetic and slightly irreverent, and his father, a former car dealer of 40-plus years, frame the whole thing as a buying opportunity. The key metric is market day supply, how many days it would take to sell all existing inventory at the current daily sales rate. Dealers prefer to turn new inventory every 90 days. Anything above that means floor plan carrying costs are piling up and dealers are increasingly motivated to deal. Running down the list from 10 to 1. Number 10, Buick Envision, 13,000 plus units on lots, 227-day supply, around $46,000. Number 9. Alfa Romeo Stelvio, only 183 units nationwide, 229 days, nearly $60,000. Number 8. Jeep Wrangler 2-door, and the Sun flags this as surprising, 8,000 units, 230 days. That's another Stellantis brand, and they start noting the pattern. Number 7. Maserati Grecale, 249 units, 233 days, nearly $100,000. Number 6. Mercedes-Benz EQS, first EV on the list, 324 units, 243 days, $105,000 to $112,000. The father calls it an electric boat anchor. Top 5. Number 5. Audi SQ7, which has appeared on these monthly lists repeatedly, 402 units, 255 days, around $105,000. Number 4. Alfa Romeo Giulia, 150 units, 270 days, combined with the Stelvio, that's only about 333 total Alfa Romeo vehicles available nationally. The hosts remark it's a terrible time to be an Alfa Romeo dealer. Number 3. Polestar 4, 658 units, 318 days, around $70,000, with the added twist that the U.S. government has decided Polestar cannot sell new cars in the U.S. starting next model year. Dealers are stuck trying to move remaining inventory with no future allocation coming. Polestar dealerships are reportedly expected to convert into service-only centers. The hosts explicitly say negotiate hard if you want one. Number 2. Volkswagen ID4, nearly 1,200 units, 349 days. The hosts joke that a VW salesperson might chain you to the desk if you walk in showing any interest. Number 1, and the Sun called it an abomination, the Dodge Charger Electric. Nearly 11,000 units sitting on lots, only 1,261 sold in the last 45 days, 385-day supply, at nearly $60,000. And a dealer partner confirmed selling one at 48% off MSRP. The father delivers the eulogy. When the Charger was an ICE muscle car, people wanted it. As an EV, it became an artificial muscle car nobody asked for. The overall takeaway: if you want maximum negotiating leverage right now, target Stellantis EVs and the Polestar 4 specifically. If you've always wanted an exotic at a discount, Alfa Romeo and Maserati are as accessible as they've been in a long time. And before you go to any dealership, visit carrydge.com/slowest to look up slow sellers specific to your state and city. On the gear side, Linus Tech Tips did a film scanning comparison with returning guest Brandon Lee, Linus's original camera operator, who now has his own channel called Brandon Y. Lee. The hook is the HP FilmScan 700, sent by HP for evaluation, and the broader question is whether you actually need to pay a professional lab to digitize your film or slides. Brandon set the economic stakes clearly. At a place like the Lab Vancouver, developing a 35 roll costs about $12 Canadian. Adding scans more than doubles that cost for 6 MB files and triples it for 18 MB files. The HP FilmScan 700 pays for itself after roughly 22 rolls. That's the core financial argument. 3 home methods compared against professional lab results. The Epson V550 flatbed, Brandon's own unit, bought second-hand for around $100 Canadian. The HP FilmScan 700, and a camera rig with a mirrorless and macro lens, which they mention but don't demo in depth. On the Epson, Linus loads a tray of 12 frames, the scan takes over 5 minutes, and he actually jokes it made him more excited to see the results due to the delayed gratification. The output is TIFF format for archival quality. Results show minor dust and slight scratching from not being maximally careful with the negatives. Colors are decent with a nostalgic, vintage feel, but Brandon notes Kodak Gold should look warmer. On the HP, it scans 1 frame at a time, feeds film through a channel, outputs JPEG by default, saves to SD card. USB is a pull from the SD card, not a direct computer connection. The real-time preview is a key practical advantage. You immediately see if there's dust or a hair, versus waiting 5 minutes on the flatbed, but the quality comparison tells the story. The Epson produces better image quality, softer, more filmic, retains dynamic range. The HP output has too much magenta, looks over-sharpened, and doesn't capture Kodak Gold's warmth. though applying the HP's own color adjustment feature does improve things meaningfully. The professional lab scan is the clear winner aesthetically. Colors are exactly what Kodak Gold should look like: correct warmth, genuinely filmic quality. But it costs significantly more per roll and requires drop-off and pickup. Key limitation of the HP that matters for many people: it only scans negatives and slides. Physical 4x6 prints, which many people have in shoeboxes from earlier decades, require a flatbed anyway. That's a meaningful gap. Target customer breakdown. For hobbyists who primarily shoot digital but dabble in film, Brandon would choose the Epson over the HP for image quality. For people who don't shoot film but have a backlog of negatives or slides to archive, the HP makes a lot of sense. It's fast, simple, and doesn't require Lightroom skill. Linus adds his huge tech tip: buy used, scan everything, then resell and potentially break even. Or offer it as a digitization service to your social circle. The most personal moment came when Linus pulled out negatives from his aunt that might contain childhood photos of him. They scanned them on the HP and found what appears to be an 8 or 10-year-old Linus in a tie, which he confirms he still can't tie himself, a shot of Lions Gate Bridge, a raccoon on a garbage can, and a car he believes contains his uncle. Brandon noted he'd never seen a young photo of Linus despite knowing him for years. On the home theater side, Switch and Click's Tyson spent 6 months slowly convincing his colleague Betty to upgrade her living room setup. A $140 TV from Sam's Club, a side-of-the-road TV stand, and built-in speakers. And then took her $1,000 budget to Facebook Marketplace to see what he could get. The approach is pure thrifting strategy. Step 1 was a long game, 6 months of producing home theater channel content until Betty started saying things like, "I had no idea movies could sound this good, and I thought this scene was purposely almost black and white when I watch it at home." Step 2. Once she was convinced a better future existed, he talked her into handing over $1,000. The pressure is high because Betty is skeptical by nature. Anything less than a dramatic improvement risks confirming her long-held belief that upgrades aren't worth it. 3 marketplace finds. First, a Klipsch 3.1 audio bundle, Sony receiver retailing around $300, Klipsch bookshelf speakers, Klipsch center channel retailing $180 on its own, Sony subwoofer retailing $250. Combined retail over $900. He talked the seller down to $300 flat, tested it in pouring rain at the seller's location, confirmed it works. Running total, $300 spent, $900 retail value. Second, an entertainment center for $100, talked down from $150, short and long enough not to block windows, white accents matching Betty's decor. Original retail $220. Tyson and his videographer hauled it down from a 3rd floor. He was still sore 3 days later. Running total, $400 spent, $1,100 retail value. Then the hard part. With roughly $600 left, he wanted something better than a run-of-the-mill $600 TV given how much Betty had defended her old one. He checked Costco, Best Buy, OpenBox listings. Nothing felt like a winner. Then on Marketplace, filtered to $500 to $700. A 65-inch Sony Bravia XR A80J 4K OLED from 2021, retailing $2,500. It had been sitting unsold for over 2 months. He theorizes people don't shop Marketplace for near $700 TV listings. Multiple photos from different angles, a live video showing content on screen. The seller offered to let him test it before purchase. He talked it down from $650 to $600. At pickup, the seller turned out to be extremely wealthy, a car inside his house, a photo with Obama. The TV works perfectly. No stand included, planned a third-party VESA stand for about $30 on Amazon. Final total, $1,030 spent, slightly over budget, against roughly $3,600 retail value, with the OLED alone accounting for $2,500 of that. Installation day had its moments. The Sony OLED is thin but unexpectedly heavy and visibly flexes when lifted, which stressed Tyson out considerably. He had to drill a cable pass-through hole in the entertainment center. After mounting the TV, he realized it was too high, had to tear it down and readjust, and called a lunch break in frustration. The audio calibration took about 30 minutes. The receiver was misconfigured about speaker count, the TV wasn't set to proper audio pass-through, and a setting was routing center channel audio through the TV's built-in speakers. He recommends anyone who hits similar problems find a local tech on Thumbtack for around $50 rather than struggling through it. Betty's reaction was genuine but understated. She said, "Wow, this is nice," and immediately called out the HDR to Zach. In the days after, she and Jake kept coming to the office to share new discoveries. Color details they couldn't see before, sound effects they didn't know existed. Tyson's closing lesson is not specifically about OLEDs or clips, it's about buying locally used. They spent $1,030 on gear, with roughly $3,600 retail value, bought from a Ukrainian woman, an Indian guy, and a really rich guy. He closes joking that his next project is subliminally convincing Betty to fund an upgrade for his own setup. Over to the energy and EV world, the Electric Viking's Sam Evans covered a genuinely historic announcement. BYD has signed an 11.275 gigawatt-hour grid storage contract with UAE energy company Mastra for Abu Dhabi, the single largest battery storage contract in history. To put the number in perspective, Evans points out it's the battery equivalent of more than 190,000 passenger electric vehicles. The context: this is part of something called the Round-the-Clock project in Abu Dhabi. The goal is to backstop the world's largest solar array, a 5.2 gigawatt installation, with enough battery storage to deliver continuous 24-hour clean power. Total storage required, 19 gigawatt-hours, sourced across 2 contracts. Chinese company Sungrow won Phase 1 with 7.5 gigawatt-hours. BYD just took the remaining 11.275. Together, 2 Chinese companies captured the entire project, locking out Tesla Megapack, Fluence, European suppliers, and even CATL. Evans uses the moment to revisit his long-standing argument that solar plus batteries equals baseload power, a position he says has been contested by PhD-level critics. He frames Abu Dhabi's project as definitive real-world validation. No coal, no gas peaker plants, no wind, just solar buffered by batteries running a city through the night. He takes evident satisfaction in saying the UAE essentially told his critics they were wrong. On the apparent contradiction of BYD fulfilling this contract while reportedly having trouble supplying enough batteries for its own vehicles. This contract doesn't use the new Blade battery version 2. It uses the existing first-generation BYD Blade battery, which is sufficient for stationary grid storage where high energy density and fast charging aren't required. The engineering architecture he highlights is BYD's proprietary hand system configuration, which uses a massive 2,710 amp-hour dedicated lithium iron phosphate cell, over 300% larger in physical volume than standard cells. Fewer total cells mean fewer mechanical connections, fewer failure points, simpler thermal management, and lower manufacturing costs at this scale. Simplified thermal management alone is a significant cost driver in large deployments. BYD's 2025 revenues exceeded $119 billion, even as margins have slipped. That financial scale gives them runway to simultaneously invest in sodium-ion batteries, solid-state cells, and expanded LFP production. His macro argument, BYD's vertical integration, making cells, building containerized software systems, and funding multi-gigawatt deployments all in-house, is essentially an insurmountable competitive advantage. He briefly notes as an aside that Tesla now uses Sungrow LFP batteries in its standard range Model Y and Model 3, which is quietly remarkable given the context. Also from the Electric Viking, Sam Evans covered what he treated as a genuinely landmark moment in the Australian EV transition. The CEO of Ampol, one of Australia's only 2 remaining oil refiners, went on national television and admitted that petrol has no long-term future. Evans was triumphant throughout, treating this as a years-long vindication. The CEO is Matt Halliday, appearing on ABC with journalist Alan Kohler. Halliday said profits from petrol sales are declining as EV adoption accelerates and that refining and selling petrol will one day be phased out entirely. Evans emphasizes the significance of this coming not from an activist or politician, but from the head of one of the country's largest fuel companies. The supporting data is striking. Australian EV market share hit 16.4% in April, 20% in May, and 24% in June. Nearly 1 in 4 new vehicles sold in June was fully electric. The Tesla Model Y was the best-selling car in the country in both May and June. Petrol vehicle sales fell 30% in each of those 3 months, and petrol vehicles now sit at roughly 24% market share. Evans stresses that petrol and electric vehicles are within about 1.5 percentage points of each other, and EVs are simultaneously getting cheaper with longer range and faster charging every year. The structural problem Halliday described. Australia has only 2 operational refineries, Ampol's Lytton refinery in Brisbane and Viva Energy's plant in Geelong, together producing about 20% of the country's fuel. As petrol demand falls, Halliday has to find a way to shift output toward diesel and jet fuel while managing a petrol surplus. In his own words, once you have to load surplus petrol onto a ship and export it, it becomes very, very, very expensive. Evans calls this the death spiral: falling demand, stranded product, shrinking margins. The most notable exchange on air. Kohler asked directly whether Ampol would make less money if all petrol customers switched to EVs overnight. Halliday didn't deny lower margins, but he stated something the oil industry has spent 20 years denying: that EV charging can be a profitable business. Ampol already has more than 350 charging bays across service stations and shopping centers, and is tracking postcodes, EV arrival data, and fleet customer patterns to build out strategically. Halliday's argument is that while margins per transaction are lower, EV customers charge more frequently, and Ampol can leverage its real estate footprint. Evans pushes back on one point: Halliday's assumption that diesel is safe. Evans argues electric trucks at 700 to 800 kilometers of range are already superior in longevity and economics, and diesel demand will fall too, though he concedes jet fuel may have a longer runway. He closes with characteristic bluntness. When fuel companies themselves are planning for the end of petrol, the debate is over. This is not ideology, it's not feelings, it's just arithmetic. Rounding out the EV and battery coverage from the Electric Viking, Evans covered a story he described as under the radar, but potentially transformative. Chinese sodium-ion battery manufacturers are pivoting from coconut shells to anthracite coal as the raw material for hard carbon anodes, and the results are dramatic. He opens by acknowledging how absurd the premise sounds before explaining that it's entirely real. The physics: sodium ions are physically larger than lithium ions, and that size difference causes them to destroy conventional graphite anodes. The solution is hard carbon, a specialized material with a disordered microstructure that sodium ions can intercalate stably. Historically, the industry standard feedstock for hard carbon was charred coconut shells from Southeast Asia, which produce non-graphitizable carbon with exactly the right microstructure. The supply crisis. China has no meaningful domestic coconut production. Their domestic tropical supply supports roughly 6.3 gigawatt-hours of sodium-ion battery production per year. Projected Chinese sodium-ion demand by 2027 is 100 to 300 gigawatt-hours. That gap is enormous. Beyond scale, the supply chain is fragile. A single weather event or logistics disruption in Southeast Asia could halt vehicle assembly lines. The coal-based pivot and the yield comparison are the centerpiece of the story. Processing coconut shells into battery-grade hard carbon produces a yield of only 2.5%. 100 kilograms of coconut shells gives you 2.5 kilograms of usable material. Processing anthracite coal through specialized high-temperature techniques yields 45% usable hard carbon. Evans describes this as an 18-fold improvement and calls it a complete no-brainer from an industrial efficiency standpoint. This is not combustion. The coal is being chemically processed, not burned. The cost impact. Switching to coal-derived anodes has dropped hard carbon anode costs by $4,400 per ton, reaching an all-time historical low. The roadmap target is to push costs below $2,944 per ton. Evans argues that once this price point is reached, the cost gap between budget EVs and ICE vehicles doesn't merely close, but reverses in EVs' favor. He preemptively addresses the PR problem. Yes, critics will say, you're making batteries with coal. He counters that the anode is a small portion of the total battery, and the absolute quantities of coal involved are modest compared to burning coal for power generation. He doesn't fully dismiss the concern, but minimizes its practical significance. He closes with a note on energy density. Goshen High-Tech has announced a sodium-ion battery achieving 262 watt-hours per kilogram, which he notes is higher than current LFP energy density. This raises the possibility that sodium-ion could expand from the budget EV segment into the mid-market, which Evans treats as a genuinely exciting development. Also from the Electric Viking, Evans got a first-look drive of the Genesis GV60 Magma, Genesis's first high-performance production EV, filmed in Canberra in winter conditions. He frames it up front as a preview, not a full review. The proper track session comes later. The specs first: 84 kWh battery, 2 motors producing 448 kW in standard mode, 478 kW, and 790 Nm of torque with launch control boost engaged. 0 to 100 km/h in 3.4 seconds. 0 to 200 in 10.9 seconds. Top speed 264 km/h. Notably high for an EV, most are limited to around 200 even with strong power figures. He's deliberately low-key about the straight-line numbers, pointing out he's driven a car that hits 0 to 100 in 2.1 seconds. What he's actually interested in is whether this car handles corners at speed. That's where the chassis story gets interesting. The suspension geometry has been completely recalibrated versus the standard GV60. There's stroke-sensing electronically controlled suspension, an electronic limited slip differential on the rear axle, and forged 21-inch wheels with 275 Pirelli P0 tires, close to race rubber without being full slicks. The braking he's particularly impressed by. He's driven performance EVs where the braking felt inadequate at high speed, which made it scary. The Magma has 400 front discs with monoblock calipers, a claimed 100 to 0 stopping distance of 33.8 meters, and a sport braking mode that increases braking force by 15% at high speeds. High-performance battery thermal management is designed to keep the pack at optimal temperature during repeated hard laps. He calls this a critical differentiator since many powerful EVs throttle performance when the battery overheats after sustained hard driving. Driver-focused features: drift mode for throttle steering, a virtual gear shift that he defends on the grounds that drivers consistently report it helps them judge speed on track, and a Magma mode instrument cluster showing motor temperature, battery temperature, and G-force readouts. He interprets the G-force display as Genesis explicitly encouraging track use. Interior: 27-inch OLED display, chamood suede-like upholstery with orange stitching comparable to Alcantara, 17-speaker Bang & Olufsen audio. Warranty is 5 years unlimited kilometers, 5 years free servicing. He flags 2 notable gaps from Genesis: no official range figures or DC charging speeds released. He speculates DC charging is likely 350 kW consistent with other 800-volt Hyundai Group vehicles. The 2 catches: price and platform sharing. In Australia, approximately 130,000 Australian dollars, roughly 86,000 US dollars, 42,000 Australian dollars more than the standard GV60. He says it's probably worth it, but is candid it's out of his personal range. And under the skin, the Magma shares its 84 kWh battery, ELSD, virtual gear shift, and drift mode software with the Hyundai Ioniq 5N, which costs roughly 10,000 US dollars less. Buyers are primarily paying for the Genesis brand and more luxurious interior. He closes with an editorial wish. What he'd personally love is a lightweight, affordable performance hatchback at half the power, half the weight, half the price, with genuine track credentials. He promises a full review after the track session and an Ioniq 5N racetrack comparison video the following week. Unfortunately, the video from Indie Game Business on why great games still fail, with Darren Williams from MinMax Game Consulting, came in with a broken transcript, just a boilerplate error message rather than actual content. I can't give you real notes on that one without fabricating, so I'm flagging it and moving on. Similarly, the AI engineer talk, Chat and Citations Won't Save Your Vertical AI, by Atul Ramachandran of Filed Inc. had no actual transcript, just a system message placeholder. The title suggests a compelling argument about the limits of standard RAG approaches in vertical AI products, but without the real content, I can't responsibly summarize it. Worth tracking down if vertical AI is on your radar. The AI engineer talk on securing and building with OpenClaw by Nick Taylor from Pomerium also came in with a broken transcript. Given that OpenClaw came up in several other talks today, Jeffrey Lee Chan built his whole development workflow around it, and DIY Smart Code covered it as a framework built on the same Pi core as Flue. This talk on the security side would have been a nice complement. If you have time to go back and watch one missing piece, this might be it. The AI engineer talk from Chris Noring of Microsoft on how the developer role is shifting from writing code to designing systems also came in with no real transcript content, just a placeholder. Given the title, it sounds thematically connected to everything else from the conference today, but I don't have anything real to report on it. And finally, the talk credited to Daniel Han from Unsloth on special topics in kernels, reinforcement learning, and reward hacking in agents came in with a completely mismatched transcript. What was submitted appears to be a general explainer about the digital divide, with no connection whatsoever to the stated topic. No kernels, no RL, no agents, no Daniel Han. Clearly a processing error somewhere. Worth going back to watch directly if that topic interests you, because based on Unsloth's track record, it was probably quite good. That's everything from the last 25 hours. 4 of the 24 videos came in with broken or mismatched transcripts, so you may want to circle back to those directly, particularly the Unsloth kernels and RL talk and the OpenClaw security session. The through line of the day was really the AI engineering world figuring out how to build reliable, cost-efficient agent systems at scale. From Theo Morning, a brand that got swallowed by the machine, to Rushabh Doshi building an entire company brain for the price of a used car. Good stuff all around.